Hi, statistics students. I'm going to go over using your calculator to do two-proportion hypothesis testing. So looking at Chapter 6, Section 9, in analysis of a poll of 800 Quebecers, 28% thought that the province of Quebec should be separate from Canada. Another poll of 500 Texans found that 18% thought that the state of Texas should be separate from the United States. So we come to the first question. It wants to know about the numbers or the counts for people of Quebec and people of Texas. So, calculator time. It's just pretty simple. 0.28 times 800 and 0.18 times 500. So 224 and 90. 224 and no idea what just happened there. Okay, and 90. Okay, why do we need to use this? Well, it's just going to help us do the calculator. So let me go ahead and pull this up. So we go to Stat, and right here, number 6 is a two-proportion z interval. So 224 out of 800. Oh, that's nice. Already in there. Okay, 90 out of 500. Now, before we get to the test, we're going to have to decide about the null hypothesis. In this case, a pooled proportion. So let me get there. Okay, I'm going to quit that. So I'm going to pool the numbers that I've got. So I've got 224 and 90 people. So these are the people that think, yes, we should be separate. So, and then altogether we had 1,300 people. Oh, whoops. I need to say divide by. Okay. Let me just clear that out. Okay. The answer is in yellow letters above my negative sign. So answer divided by 1,300. So my pooled proportion, I need 3 decimal places, 0.242. 0.242. Can we conclude the two proportions are different? Well, first of all, we start off saying that they are not different, that they are equal. And then we want to, when we just say differ, then we're going to use a two-tailed test. So that will give us P1 and P2 not equal to each other, which is really going to help us when we get to the calculator. So let me go ahead and pull that up. Go back to Stat, Test, and I was looking for number 6. So in this case, we're testing a not equal for the alternative. I can do the draw menu. I always like that. Okay, Z is 4. So these proportions are about 4 standard deviations apart. P-value is about 0. If I want to get a little more accurate to 2 or 3 decimals, I can go back to Stat, Test, 6, come down and just say calculate instead of draw. And you notice here's the pooled. P hat is the pooled proportion. And here's a Z. And, you know, that's 4 zeros and then a 5. I'm going to say 0. So 4.1, yeah. 4.10 and 0. The conclusion of this test, I would definitely reject the null hypothesis. And yes, I can conclude that those are different. Okay. So there's one problem. Let me do one more. I'm coming down to your last homework problem. Okay, in this case, we actually have numbers, but that's okay. Hormone replacement therapy. So is this good? Bad? Do we want to be in the placebo group? Do you get cardiovascular disease? breast cancer, cancer, fractures. Okay, does it really help? So we want to know a test statistic and a p-value, but we've got lots of numbers here, so let's figure out what we're talking about. Test for proportion of women who get cancer of any kind, cancer taking a placebo. So we're just looking at these groups right here. So what I need to do is figure out how many people were all in there. Okay, so here's my numbers. All right, happy calculator time. Stat. Test number 6. So women who got cancer, 502 out of 8506. Nice that they gave us the numbers. Okay, placebo group who got cancer, 458 out of the 8102. Okay, so we need to know which way do we go? Do we go two-tail, one tail, left, right? Which one do we want? So we come down here. Is there a difference? All they want to know is a difference? I thought they were shown to significantly increase risk. I'm going to go for the difference of two proportions. Yeah, I'm going for the right. I think that this group was bigger than the other group. So I'm going to make it a right tail test. Enter. Draw just to see that. Okay, that's not very significant. So 0.687 for my test statistic. 687 with a p-value. So that's a third of a standard deviation away. That's really likely due to chance. So 0.246. 0.246. Does it? Nah, it really doesn't. Submit answer. Okay, so. And it says there was one mistake. It doesn't like my p-value? I would look at the hint, but I think it's not telling me. Are they trying to say that it was a two-tail test? When they just test for a difference? Let me try that and see what happens. Isn't it fun trying to second guess Wiley plus? Number 6. So let's test for a difference. Enter. Enter. Okay, so that would give me 0.492. They like that one better? They do. Okay, so I guess they were doing a two-tail test rather than a one-tail test. Okay. It's tough to know. But there we go. Have fun with your homework.